Section 7.5 is solving rational equations. So for the first example, we'll solve these two proportions. So a proportion is like when you have an equation where it's basically like a fraction set equal to a fraction. And when we have a proportion, we can solve it by cross multiplying. So for the first one, 2 over x plus 2 equals 10 over 3x plus 2. So we have, like I said, like just a fraction equal to a fraction, like no other terms on either side. So if we have that set up, we can cross multiply. So cross multiply, we're going to multiply 2 times 3x plus 2. We're just going to go diagonally across the equal sign. So that would just be 2 times 3x plus 2. You can do it in your head if you want. It's up to you. And then we'll go the other way. So 10 times x plus 2, the other way across the equal sign. We're basically just like multiplying opposite numerator and denominator in both directions. And then for 2 times 3x plus 2, we can distribute. So 2 times 3x is 6x. 2 times 2 is 4. And then 10 times x, 10x. And 10 times 2 is 20. And then from there, we're just solving like a regular equation. So the first thing we would want to do is get our x's on one side of the equal sign. So I'm going to subtract this 6x over. So 6x minus 6x cancels out. I'm left with 4 equals 10x minus 6x is 4x plus 20. And then now time to isolate our x. So I'm going to subtract the 20 over. So 4 minus 20 is negative 16 equals 4x. And then lastly, just divide both sides by 4. So we end up with x equals negative 4. One thing you have to keep in mind with rational equations is you might end up with a solution that makes the original denominator 0. It doesn't in this case, but you always want to double check that whatever answer you get doesn't make the denominator 0. This one's good. Doesn't make this denominator 0 or this one 0. And then for number 2, it's 1 over 2x plus 5 equals x over 11x plus 8. So same thing, we have a proportion where it's just one fraction equal to one fraction, so we can cross multiply. So I can multiply 1 times 11x plus 8, so it's just 11x plus 8. And set that equal to x times 2x plus 5. And then distribute the x to the 2x plus 5. So 11x plus 8, leave that alone for now, and then equals x times 2x is 2x squared. And then x times 5 is 5x. And then now we have a quadratic because we have an x squared term, so we should get the equation in standard form. So I'm going to subtract the 11x over first. I'm just going to move everything to this right side so that one side of the equation becomes 0. So 11x minus 11x cancels out. I'm left with 8 equals 2x squared, and then 5x minus 11x is negative 6x. And then I have to subtract the 8 over. So 0 equals 2x squared minus 6x, and then just minus 8. And then now we can go ahead and factor this. I'm going to rewrite it up here, just because I'm running out of room. So we can go ahead and factor. When we factor, the first thing that we should check for is GCF. So between 2, 6, and 8, I can factor out a 2 there. So factor out, or I can divide out a 2, doesn't really matter. I'll just factor it out. So it leaves me with x squared minus 3x minus 4. And then now the coefficient of x squared is 1. So I'm just looking for factors of negative 4 that add up to negative 3. So it would be negative 4 and positive 1. That means when I go to factor that, the 2 can just stay out in front, and then it factors into x minus 4 times x plus 1. And then now I can set each factor equal to 0. So if I don't really need to worry about the 2, just the factors with the x's in it. So if I said x minus 4 equal to 0, x plus 1 equals 0 for x minus 4, add the 4 over, get x equals positive 4. For x plus 1, subtract the 1 over, get x equals negative 1. And then same thing, just kind of double check that they don't make the denominator 0. So if I plug in 4, 2 times 4 is 8, plus 5 is not 0. Same thing here. If I plug in -1, 2 times -1 plus 5 is 3, so that's okay. And then 11 times -1 plus 8 would not be 0 either. So x equals 4 and x equals -1. Okay, so now we're moving on to problems that are not a proportion. So remember, the proportion, let me just backtrack a little. A proportion is just an equation where it's just one fraction equal to one fraction. So both of these were proportions. The next problems that we're going to deal with are not going to be. So one option is, I'm not going to go in too far into depth in this option, is, or sorry, let me backtrack a little. So for number 3 is 1 minus 2 over x minus 4 equals 4 over x. So this is not a proportion because it's not just this one fraction on the left side, I also have the 1 minus. So if we want to solve this as a proportion, you can. You would just have to simplify this left side by getting common denominators and then cross multiply after you get it all into one fraction. But because we're dealing with equations now instead of just expressions, we can also multiply something throughout the entire equation that clears the denominator. So this is not something that you can ever do unless it's an equation. So like with section 7.3, 7.4, where it was just an expression and we were simplifying it by getting common denominators for 7.4, you can't do this method there basically. So if you have an equation, you can do this. Basically, if not, you cannot. So what I'm trying to get at is if we find either the LCD, or you might hear me say LCM, and they're pretty interchangeable. If we can find the LCD, or the least common denominator, we can take that and multiply it through the entire equation, and that gets rid of all the fractions. So in order to find the LCD is just the least common multiple of all the denominators. So it's pretty much interchangeable. So if we look at the two denominators that we have an x minus 4 and an x. So I think it was in 7.4, we had to find the least common multiple. So that's what we're going to do here, is just find the least common multiple between the two denominators. Like I said, least common multiple, least common denominator, pretty much interchangeable here. So if I want to find the LCM between x minus 4 and x, so remember, this is where we have to take each different factor and then take the highest power that we see at each factor. So right now I just have two different factors. I have an x minus 4 and I have an x. So that means that the least common multiple between the two factors is going to be x times x minus 4. If this was like an x squared, this would have to be an x squared, but it's not, so we're good there. So if I want to get rid of the fractions and clear out the denominator, I can take my LCM and multiply it throughout the entire equation. Because we have an equation, if I multiply every term in the equation by the same number, it doesn't change like the balance of the scale basically. It's like if I had a scale and I added or I doubled the amount of weight on both sides, it would stay balanced because it's both being doubled. So I'll take my LCM, x times x minus 4, and I'm going to distribute into the equation. So when I multiply x times x minus 4 times 1, that just stays the same. So that's x times x minus 4. And then when I multiply it by the 2 over, or the minus 2 over x minus 4, the x minus 4 and the x minus 4 are going to cancel out. So I'm just really multiplying the 2 and the x. So minus 2 times x. And then when I multiply it by the 4 over x, or I'll throw it on my equal sign, when I multiply it by the 4 over x, the x and the x are going to cancel out. So I'm just multiplying 4 by x minus 4. So just 4 times x minus 4. So you're able to, most of the time, or if you have something in the denominator, one of the factors, at least one of the factors of the LCM is going to cancel out. And then from here, we're just simplifying and solving this equation now. So I'm going to backtrack. I'm just going to talk about that one more time. So I multiplied x times x minus 4 by 1. That's how I got this term. When I multiplied x times x minus 4 by 2 over x minus 4, the x minus 4 just canceled out, so I was just left with 2x right here. And equals, when I multiplied 4 over x by x times x minus 4, the x's canceled out, so I was just really multiplying it by 4 times x minus 4. Okay, and then we can distribute the x. So x times x is x squared. X times negative 4, so negative 4x. Bring down the minus 2x. Distribute the 4 here. 4 times x is 4x. 4 times negative 4 is negative 16. And then we want to get this equation in standard form because it's a quadratic. So we can combine the negative 4x and the negative 2x into negative 6x. So x squared minus 6x equals 4x minus 16, and then we can subtract the 4x over. So x squared minus 10x equals negative 16, and then I'll add that 16 over, and I'm going to rewrite it up here. So when I add the 16 over, I'm left with x squared minus 10x plus 16 equals 0, and then now I have a quadratic and the coefficient of x squared is 1, so I'm just looking for factors of 16 that add up to negative 10. So it would have to be negative 8 and negative 2, and then so this factors into x minus 8 times x minus 2, and then we can set each factor equal to 0, so x minus 8 equals 0. X minus 2 equals 0 for x minus 8. Add the 8 over, get x equals positive 8, and for x minus 2, add the 2 over and get x equals positive 2. And then just verify that they don't make the denominator 0, so neither 8 or 2 would make this denominator 0, and this is just x. So. Okay, for number 4, 4x plus 1 over x plus 1 equals 12 over x squared minus 1 plus 3. So same thing here, we can get rid of the denominator by clearing out or finding out the LCM and LCD in order to clear it out. But in order to do that, we have to make sure that we know the factors in the denominator. So like x plus 1, that's its factor, it can't be factored any further. But x squared minus 1 can be factored further. That's a difference of squares. So that factors into x plus 1 times x minus 1. So now we can see all the factors of the denominator and we're able to figure it out. So that I'm going to write this off to the side here. The least common multiple, we'll use least common denominator. So we know we're looking at the denominator. Like I said, interchangeable. We have a factor of x plus 1 right here, and then we have a factor of x plus 1 and a factor of x minus 1 right here. So the two different factors are x plus 1 and x minus 1, and you just have to take the highest power of each one, so you don't need to like combine them. So like just because this is an x plus 1 and x plus 1, the LCD is not x plus 1 squared. You just take the highest power of each like individual one. So x plus 1 of the first power, x plus 1 of the first power, so this is just x plus 1 of the first power, and then x minus 1. So that's what I'm going to have to multiply through. So I'll multiply the entire equation by x plus 1 times x minus 1. So when I distribute that in, when I multiply 4x plus 1 over x plus 1 times x plus 1 times x minus 1, the x plus 1 and the x plus 1 here, they cancel out. So I'm really just multiplying 4x plus 1 times the other factor, the x minus 1. So one more time, when I multiplied this fraction by the two factors, the x plus 1 and the x plus 1 cancel each other out, so I'm just multiplying 4x plus 1 times 4x minus 1. And then when I distribute it to the next term, so equals 12 over x plus 1 times x minus 1. So now because both of these factors are what I'm multiplying in, so 12 over x plus 1 times x minus 1, the x plus ones cancel out, and the x minus ones also cancel out, and I'm just left with 12. It's like multiplying 12 by 1 because these cancel out and these cancel out. So equals 12. And then plus 3 times, I'm just multiplying 3 times x plus 1 times x minus 1 because there's nothing in the denominator that cancels out part of these, or one of these factors. So plus 3 times x plus 1 times x minus 1. And then we'll start working towards getting this equation in standard form. So for 4x plus 1 times x minus 1, we need to FOIL it. So 4x times x is 4x squared. 4x times negative 1 is negative 4x. X times 1, so plus x. 1 times negative 1, so minus 1. Equals 12. And then plus 3 times, if I FOIL x plus 1 times x minus 1, I get back to x squared minus 1. Because this was just x plus 1, x minus 1 was just x squared minus 1 factored. And then we can combine like terms on the right side. So 4x squared, negative 4x plus x is negative 3x minus 1. And then 12 plus, if I distribute the 3 in, 3x squared minus 3. And then 4x squared minus 3x minus 1. I can combine like terms over here, so 12 and negative 3, so I have 3x squared plus 9. And you can do this in as many or as few steps as you need. And then I'm just going to rewrite this because I kind of ran out of room to subtract things below. So 4x squared minus 3x minus 1 equals 3x squared plus 9. And then if I want to get everything on one side of the equal sign, I'll have to subtract that 3x squared over. So 4x squared minus 3x squared is just x squared minus 3x minus 1 equals 9. And then finally just subtract that 9 over. So x squared minus 3x, and then negative 1 minus 9 is negative 10 equals 0. And then now we're looking for factors of negative 10 that add up to negative 3. So those factors would have to be negative 5 and 2. So that means that this factors into x minus 5 times x plus 2 equals 0. And then finally just set each factor equal to 0. So x minus 5 equals 0, x plus 2 equals 0. For x minus 5, add the 5 over, get x equals positive 5. For x plus 2, subtract the 2 over, get x equals negative 2. And then check to see that they don't make the denominator 0. So 5 wouldn't make either of these 0, and neither would negative 2. So x equals 5 and x equals negative 2. Okay, number 5. So 4x over x squared minus 9 equals x minus 1 over x squared minus 6x plus 9 plus 2 over x plus 3. So we have a bunch of different things in the denominator, but we need to figure out all of the different factors, and right now not everything is factored. So first we can factor the x squared minus 9. That's a difference of squares. So like a squared minus b squared, kind of like this x squared minus 1 was. So x squared minus 9 factors into x plus 3 times x minus 3. And then x squared minus 6x plus 9, we're looking for factors of 9 that add up to negative 6. So that'd be negative 3 and negative 3. So that can, because we get the same like two numbers, we can write it as a binomial squared. So that factors into x minus 3 squared. And then now we can see all the factors. This is already factored as much as it can be. So if I want to figure out my least common denominator, I have to take each different factor. So I see there's a factor of x plus 3, factor of x minus 3, the same factor x minus 3, and the same factor x plus 3. So the two different like types of factors that I see are x plus 3 and x minus 3, and then I just have to take the highest power of each factor. So for the x plus 3, the highest power there is just 1. And then for x minus 3, the highest power between those two is there's a squared. So the LCD would be x plus 3 times x minus 3 squared. So that's what I have to multiply throughout the entire equation. So multiplying the x plus 3 times x minus 3 squared throughout, make it a little bit easier to see. So if I distribute this in, so x plus 3 times x minus 3 squared, if I multiply that by the first term, the 4x over x cubed, or sorry, x squared minus 9. So the 4x will end up getting multiplied by, the x plus 3 is going to cancel out the x plus 3, and then the x minus 3 is going to cancel out 1 out of the 2, so I'm still multiplying 4x by x minus 3. So one more time, when I multiply this into the first term, the x plus 3 and the x plus 3 cancel out. The x minus 3 cancels out 1 of the 2, so I still have an x minus 3 that I'm multiplying by the 4x. And then equals, and then I'm multiplying x minus 1 over x minus 3 squared by x plus 3 times x minus 3 squared. So the x minus 3 squared cancels out the x minus 3 squared. So I'm just multiplying the x minus 1 by the x plus 3. Okay, one more time. The x plus, when I multiply these two, like x minus 1 over x minus 3 squared by this, the x minus 3 squared and the x minus 3 squared cancel out, so I'm just multiplying x minus 1 by x plus 3 right here. And then plus 2 over x plus 3 times x plus 3 times x minus 3 squared. So the x plus 3 and the x plus 3 cancel out, so I'm multiplying 2 times x minus 3 squared. And then we can start simplifying. So if I distribute the 4x in, 4x times x is 4x squared. 4x times negative 3 is negative 12x. If I FOIL x minus 1 times x plus 3, x times x is x squared. X times 3 is 3x, and negative 1 times x is negative x, so together that's 2x. Negative 1 times 3 is negative 3. And then plus 2 times x minus 3 squared. We factored x squared minus 6x plus 9 into x minus 3 squared. So these are the same thing. So I can write this side by side and I could FOIL it, but I'm just going to get back here. So I'm going to multiply 2 by x squared minus 6x plus 9 just to save some steps. So 2 times x squared is 2x squared. 2 times negative 6x, negative 12x. And then 2 times 9, so plus 18. Just because the x squared minus 6x plus 9, these are interchangeable, it's just written in a different form. And then we can start combining like terms. So 4x squared minus 12x. And then I have a x squared and a 2x squared, so together that's 3x squared. I have a 2x and a negative 12x, so that's negative 10x. And then I have a negative 3 and an 18, so that's positive 15. And then I can get them in standard form. So I'm going to subtract the 3x over, the 3x squared over, just to keep it positive x. So when I do that, 4x squared minus 3x squared is just x squared minus 12x equals negative 10x plus 15. And then add my 10x over. So x squared, negative 12x plus 10x is negative 2x equals 15, and then just subtract the 15 over. So x squared minus 2x minus 15 equals 0. And then now we're ready to factor. So because this coefficient is 1, we're just looking for factors of negative 15 that add up to negative 2. So it would have to be negative 5 and 3. So that means x squared minus 2x minus 15 factors into x minus 5 times x plus 3 equals 0. And then I can set each factor equal to 0, so x minus 5 equals 0, x plus 3 equals 0 for x minus 5, add the 5, get x equals 5, and then for x plus 3, subtract 3, get x equals -3. And then just check to see if it makes the denominator 0. So with 5, we're good, but with -3, if I plug in like x equals -3 to, I think actually all of them, or no, maybe just these two, but if I plug it in right here, that makes the denominator 0 because it'd be -3 plus 3, and then if I plug it in right here, -3 squared is 9, minus 9 is 0, so that x minus 3 doesn't actually work, so our only solution is x equals 5. Okay, so for 6, 9 over x minus 2 plus 6 over x plus 2 equals 9x squared over x squared minus 4. So we have a factor of x minus 2, x plus 2, but the x squared minus 4 isn't factored fully. So we want to factor that. It's a difference of squares. So a squared minus b squared. So x squared minus 4 factors into x plus 2 times x minus 2. And then we could see our least common denominator pretty easily. So we have a factor of x plus 2, we have a factor of x minus 2, those same two factors are just repeated here, and the highest power on each of them is just 1, so we keep them to the first power. So I'm going to multiply the entire equation by x plus 2 times x minus 2. So when I multiply that x plus 2 times x minus 2 in, when I multiply it by the first fraction, the 9 over x minus 2, the x minus 2's cancel out, and I'm just left with 9 times x plus 2. Because x minus 2's cancel out, and I'm just multiplying it by x plus 2. And then for the next term, for 6 over x plus 2, the x plus 2 and the x plus 2 would cancel out, so I'm just multiplying 6 times x minus 2, so plus 6 times x minus 2 equals, and then when I multiply it by the 9x squared over x squared minus 4, or we know that x squared minus 4 factored in x plus 2 times x minus 2, so this denominator cancels out this completely. So because they have the same exact factors, everything cancels out, and I'm just left with the 9x squared. And then on the left side, I can start distributing everything in. So 9 times x is 9x, 9 times 2 is plus 18, 6 times x, so plus 6x, 6 times -2, so minus 12, equals 9x squared. Combine like terms on the left side, so the 9x and the 6x together, that's 15x. The 18 and the -12 together, that's 6, equals 9x squared. And then I'm going to subtract both of these terms over here to get it in standard form. So subtract 15x and subtract 6. And then that'll leave me with 0 equals 9x squared minus 15x minus 6. And then now I want to factor it, but first I need to check for greatest common factor, which is 3. So I can factor out a 3, or I can divide out a 3. You can also divide it out since it's an equation. So if I factor it out, it stays out in front. 9x squared divided by 3 becomes 3x squared, and then minus 5x, and then minus 2. And then now I have a trinomial 3x squared minus 5x minus 2, but the coefficient of x squared is not 1. So we want to use the X or box method in order to factor it. So a times c goes on top, so 3 times -2 is -6. b, -5 goes on bottom. So I'm looking for factors of -6 that add up to -5. So it'd have to be 1 and -6. And then we have to remember to write it over our a value, so over 3. And then -6 over 3 reduces to -2 over 1. So then 0 equals 3 times 1 over 3 turns into 3x plus 1. And then -2 over 1 turns into x minus 2. And then now we can set each factor equal to 0. So 3x plus 1 equals 0, x minus 2 equals 0. You don't have to worry about factors that don't have an x with it. For 3x plus 1, if we subtract the 1 over and divide by 3, you end up with x equals negative 1/3. And then for x minus 2, if you add the 2 over, you end up with x equals 2. And then just check to make sure they don't make the denominator 0. The 1/3 were good, but for the x equals 2, if I plug that in right here, it makes it 0 right away. So 2 minus 2 is 0. So that solution does not work, and it's just x equals negative 1/3. So for the next example, it says in example 6 in section 7.2, we wrote the function c equals, I think that's supposed to be 7.4 or 7.3, c equals 25n plus 1,500 over n, which represented the average cost of dollars, or in dollars, of plotting blueprints. How many different blueprints must be plotted for the average cost to be $75? Actually, I think it's in 7.2. Sorry. So if we want to figure out how many blueprints have to be plotted for the average cost to be $75, 75 is going in for C, and then we have to solve for N. So because C is representing the average cost, so it'd be 75 equals 25N plus 1,500 over N, and we want to find out what N is, the number of blueprints. So in order to solve this, I think the fastest way is just to multiply both sides by N to clear out the denominator. So times N, and then we end up with N times 75, so 75N equals, these cancel out, I'm left with 25N plus 1,500. So 75N equals 25N plus 1,500, and then we can subtract the 25N from both sides to get our N's together. $75N minus 25N is 50N equals 1,500. And then finally, to get N by itself, we have to divide both sides by 50. And then 1,500 divided by 50 is 30, so N equals 30. Or we'd have to print 30 blueprints in order for the average cost to fall to $75. Okay, the next example says Jacob can complete a project in 5 hours. Megan can complete the same project in 3 hours. How long would it take them to complete the project if they work together? So we can set up, or we can go towards creating a proportion here. So if he can, if Jacob can complete one project in 5 hours, say, we'll call the numerator the project that he's finishing over the amount of time that he's creating it, so 1 over 5. And then if Megan can complete the same project in 3 hours, hers is going to be that one project in 3 hours. And then if we want to figure out how long it would take them to complete the project if they work together, we can add those two values. And what we're finding is we're solving for how many hours it takes them to do it together. So they're completing this one project still, so still a 1 in the numerator, over this unknown amount of hours that it takes to complete the project together. So the first fraction is Jacob completing this project in 5 hours. The second fraction is Megan completing the same project, the same one project in 3 hours. And then if we want to find out how long it would take them to do it together, we have to add their 2 times. And then we're solving for the amount of time it takes them to do it together, but it's still the one project in the numerator. So in order to solve this, you can get common denominators pretty easily since they're both just numerical fractions. So I'm going to multiply, or my LCD here between 5 and 3 would be 15. So to get there, I have to multiply 1/5 by 3 over 3, and then I have to multiply 1/3 by 5 over 5 to get that denominator of 15. So when I multiply 3 over 3 by 1 over 5, that becomes 3 over 15. And then when I multiply 5 over 5 by 1 over 3, it becomes 5 over 15. So now we have our common denominator, and then equals 1 over x. And then when we're adding fractions, when we have common denominators, we just add the numerator and the denominator stays the same. So 3 plus 5 gets us 8 over 15 equals 1 over x. And then now we have our proportions. This is kind of what I was saying before, like if you really wanted to, like on example 3 through 6, like you could get common denominators and then just make the equation into a proportion. Like if I wanted to approach like number 6 that way, I would have to get a common denominator here, kind of like we did in 7-4, to add them together and then cross multiply. So now that we have a proportion 8 over 15 equals 1 over x, I can cross multiply. So 8 times x, just multiply opposite numerator and denominator. So 8x equals 15 times 1, so equals 15. And then we're solving for x, so we need to divide both sides by 8. So the 8's cancel out, and then left with 15 over 8, so 1 7/8 hours, or you can change it to a decimal. So 15 over 8 is 1.875 hours.